Assalamu alaikum. Today we are going to learn system of equations. The lesson today is about how to solve the 2 by 2 system of equations using elimination method. First, let's know about elimination. Elimination comes from the word eliminate, and the idea behind this method, in fact, is to use both variable linear equations of the system of equations to come up with one variable linear equations by eliminating one of the variable. That means we change both two variable linear equations into one variable linear equations, which is we know already how to solve that type of equations. Let's start. Let's learn how the elimination work. So suppose we have a system of equations. So given a system of equations, so a1x plus b1y equal c1. First, to solve that system using elimination, first, guys, please use the Isel test. So first, use Isel test. At least you know ahead what type of solution you're gonna end up with. Get used to that test because it's very, very helpful. Use Isel test for the type of solution you are going to end with. Okay, let's suppose that system is consistent and dependent. That means there is a solution. So let's suppose the given system is consistent and dependent. Suppose the given system is consistent and dependent. That means we already have a unique solution. We will see the case when we have infinite solution and the case when we have no solution, which means that we're gonna see the case when we have a consistent system and the case when we have consistent dependent system. So let's start with independent. Okay, let's suppose this is an independent system. So we have the system here. So let me write it here. So py equals c, a1x plus b1y equals c1. So like I say, the idea of elimination is we need to eliminate one of the variable by using both equations. First, you need to decide what you want to eliminate. So decide which variable you want to eliminate. Either you want to eliminate x or you want to eliminate y. Again, this is your choice. This is your choice. You choose what you want to eliminate. If you don't like x, eliminate x. If you don't like y, eliminate y. So keep in mind, this is your choice, but the method work for both. Either you want to eliminate the first x or you want to eliminate the y. Is the same method. It's not gonna make any difference if you start by x or y. Suppose I want to eliminate x. I don't like x. I want to eliminate x. So the idea, I don't need x. So in order for me to eliminate x, I need to make sure that the coefficient of x are the same in terms of digit, which means I can have 2x, I can have 2x, or I can have 2x, or I can have minus 2x. So in terms of digit, they have to be the same. The sign, it doesn't matter. The digit must be the same. If I have 12x, I need to have 12x. If I have 12x, I can have minus 12x. You see, the type of digit should be the same in terms of value and in terms of type of digit. So this is the idea behind. So I need to make sure that the coefficient of x are the same in terms of digit. So in that case, sometimes we can have same coefficient, sometimes not. So what we do to make sure that we have the same coefficient, we are going to look for the LCM, which is the least common multiple of A and A1. So if you refresh your memory about 7th grade, so LCM, or 6th grade, so A, so is the least common multiple of those two numbers. So let's suppose my LCM is M. Keep in mind that M is a multiple of A and a multiple of A1. So M is a multiple of A, which means that there is a number, there is R, such that M equal R times A. I want to give you an example, but let me do the second case. So M is a multiple of A1, so which means again that there is another value such as M equal T times A1. So let me give you a short example, then I will move on to my uh, elimination method. So for example, what is the LCM of 4 and 14? So I'm going to look for the least common multiple of 4 and 14, and it's 28. So go and review your LCM. So you will see that the LCM of 4 and 14 is 28. So 28 is a multiple of 4 and is a multiple of 14. So I'm going to write down 28. You see this is my A, this is my A1, and this is my M. You see 28, which is my M, is equal to what? 4 times a number. You see this is my A. So what is the number here is 7. Which you see my R is 7. And again, 28 equal, this is A1, this is M, and to get 28 I need to have 2, and this is my T. So that's the idea, because it's multiple, there is always a number times A will give me that multiple, and this is the idea we are going to use, and you can use the concept of substitution, and you're going to see it right now. So we assume that the LCM is M, and there is two number R and T, such that we have M equal, we show that M equal RA and M equal TA1. So in my system, which is I have AX plus BY equal C A1X plus B1Y equals C1, in order for me to have the same coefficient, so what I do, I multiply this first equations by R, and I multiply the second equations by T. So the idea when I have A R, it's M, and when I have A1T, is M again. So here I will have at the end, after I distribute the R on all terms, so it's going to be A RA X plus RBY equal RC, and here I will have T A1X plus T B1Y equal TC1. Now, RA is M and TA1 is M. I'm going to substitute those two expressions by their equivalent expression. So we end up having MX plus RBY equal RC, and we will have MX plus TB1Y equal TC1. As you see here, you see the coefficients are the same. They can be the same sign, they can be different sign. If those have the same sign, we subtract both equations. Same sign, we subtract both equations. Same sign, we subtract both equations. Different sign, we add the equations. Different sign, we add the equations. Different sign, we add the equations. So let's assume the sign are the same. So I'm gonna subtract. You see, I will subtract here. So this cancel out. You see, I eliminate the x. There's no more x, and here will be RBY plus minus TB1Y equal RC minus TC1. I'm going to combine like terms here because we have y here. So we will end up having y RT minus T R minus T1 equal minus T R minus T. Now left is y equal C minus T. So over RB minus T1 TB1, not T1B, just TB1. There's no T1 here. Alright, so TB1. So this will be my y. Alright, so after what I do, I take this y and I substitute it in one of those equations, either in this equations or this equations. When I substitute y, it's gonna we will have two steps in the equations with x as a variable. So we are going to solve for x. So the last steps, what we do, we substitute. Last steps, substitute the value of y into one of the equations. Any equations you want, either the first one or the second one, it does not matter. It will give you the same answer into one of the equations of the two equations of the system. And solve for x. So that's the idea. So if I go back to my system, so for example, I pick the first equations. Yes. So I have ax plus by equals c. We already have y equal rc1 over t b1. So what I do here, I substitute this y by the new expressions. So I will have ax plus b times rc minus t c1 over rb minus t b1. I hope this is my my number. So now this is equal to c. You see, this is a number. So I'm going to subtract that number both sides here, and I solve for x at the end. So this is what you need to solve for x. So at the end, normally you should get x equal c. Don't get scared about the number, how it look like. Keep in mind this is just a number. So at the end, you're going to have only a small number, small form, either 2, 3, or 5. Times by that number is going to be just a number. So minus b times rc minus tc1 over rb minus tb1. So that number will be divisible by a. So this is one normally you should get. So let me put that here. So this is the value of x you're gonna get at the end. So don't about that. So this is just an abstract presentation about how to solve the 2 by 2 system of equation using elimination method to the application. So let's pick an example, and from there you will see really how it works. So let's do some practice. So for example, if I pick that example, so let's solve for that system. So I have 6x plus 7y equals x, and minus 4x minus 3y equal minus 14. Okay, first thing I'm going to use the Isel test to see what type of solution I will come up with, or what type of system I have, either consistent and consistent. So Isel test. So the ratio, we have 6 over minus 4, and we have 7 over minus 3. So those two are different, so which means we have consistent and dependent system. The solution, I can go and solve for it. I'm sure I end up with a solution, and my time is not going to be wasted. So this is consistent and dependent. All right, so let's do it. So we have 6x plus 7y equals x, and minus 4x minus 3y equal minus 14. So here I want to eliminate the x. I can eliminate the y if I want. It's the same thing. So I want to eliminate the x. I'm going to talk about what is my m of 6 and 4. So it's 12. I mean 12 equal what times, and 12 equal what times 4. So 2 times 6 is 12, and 3 times 4 is 12, which means I'm going to multiply the first equations by 2, and I multiply the second equations by 3. So now what I will get at the end, you see, I will end up having 12x. You see, this is, okay, if I put this, you see this is your A, this is your B, this is your C, and this is your R. This is your A1, this is your B1, and this is your C1, and this is your T. So you see, this is my M, this multiple, yes. This is my R, this is my A. This is my M, this is my T, this is my A1. You see, I will get uh, 2 times 6, which is RA. RA is 12, so I'm going to substitute by 12 here, and I multiply here. The same thing here. I will have this with this and with this one. So at the end I will have what? I will have 12x plus 14y equal 12, and here I will have minus 12x minus 9y equal minus 42. Now you see the digit, are same digit. You have 2 here and 2 here with the same order. So what I do here, I have sign different. If the signs are different, I say we add. If the signs are the same, we subtract. The same sign we add, we subtract. Different sign we add. Here we have different sign, so we add here, and add here. So at the end, so this will cancel out. Here I will have 5y, and here I will end up minus 30. So I solve for y because this is one step linear equations. So I divide by 5 both sides. So my y will be minus 6. Now I got my y. You see on the previous page we have like a very crazy y. You see this is the y we find out. But look, when we use number, it's just a number. So this is what I told you. Don't get scary about the actual form of the value of y. So now y is minus 6. So I'm going to pick one of the equations and substitute y. I'm going to pick the second one, which is, I see it for in my eyes is easy. So I got minus 4x minus 3y equals 14. You see? So what I do next, I substitute minus 6 instead of y because those two are the same y, and the value of y is minus x. So I'm going to substitute this y by its new expression. So here we'll have minus 4x plus 18 equal minus 14. This is the two steps linear equations. So I solve for x, so minus 18 minus 18. So I got minus 4x equal minus 32. Now, so let me use that side here. So I got minus 4x equal minus 32. So divide by minus 4. So x will be 8. So now my solution for that system, let me use different color. So the solution will be x, y equal 8 minus 6. So this is about using elimination method to solve a 2 by 2 system of equations. Now let's see the other case. Suppose I have that system of equations. Suppose I have, for example, uh, minus 9 minus 15x equal minus 6y, and we have minus 14y minus 16 equal 10x. So this system is not in order. So what I'm going to do first, I'm going to rearrange the system first. So I will move all the x in one side and all the y on the other side. So what I do, I'm going to add 15x both sides. And here I'm going to switch the order of those two. So 10x move here, the sign will change. And you know what? Let's do this. Let me move the 14y is better. So because I have everything is positive. So I'm gonna move 14 minus 14y here. So the sign of minus 14y will become positive. So if I move minus 15 on that side, it will become positive. So my final system will be 15x minus 6y equal minus 9. And here I will have 10x plus 14y equal minus 16. So this is how this is what I will get when I do that operation. So now I'm going to use the Isel test to check what's going on here. So 15 over 10 and minus maybe I choose the wrong system here. Yeah, I choose the wrong system, so sorry guys. So normally here should be 4y. So here when I move the 4y's become negative. Sorry for that. So normally I should, I'm planning to do one of the other cases. So this is not 14, is 4y. So I move the 4y, so it's become minus 4y. So now I do my Isel test. So here I will have minus 6 over minus 4. So this will be, if I simplify here, I will have 3 half. And here if I simplify, I will have 3 half. They are equal. So I'm gonna check the ratio of the result. So minus 9 over 6 minus 16, which is 9 over 16. It's different, which means the system is inconsistent system and there is no solution. So this is inconsistent. So which means no solution. So how do I know if it's no solution or if it's no solution? By using elimination. So let's do the idea. So here I will have, after I'm going to pick that system, which is after I organize it. So it's going to be 15x minus 6y equal minus 9. And here I will have 10x minus 4y equal minus 16. So first thing, like I told you in the previous lesson, If you can simplify, simplify the system. More you simplify the system, more it's getting easier to solve. So here I can divide by 3 and here I can divide by 2. So if I divide the top by 3, because the 3 is the common factor, and divide here by 2 because 2 is the common factor. So what we will get at the end, I will end up having 5x minus 2y equal minus 3, and here I will have 5x minus 2y equal minus 8. You see now we end up having the same coefficient, so the coefficient are the same of x. So, and even though the coefficient are the same of y and the same sign, so here what I do here, I will subtract because they are the same sign and they are equal. So I will subtract, so this will cancel out, this will cancel out, so I will have 0 here equal, and when I subtract this, I will end up having 5, which is false. Then let's say no solution, because this is a false statement, no solution. So this is how we solve an inconsistent system using elimination. So for the next one, we're going to see for consistent dependent. So suppose I have minus 14y minus 7 minus 7x equal 0. And we have 20x plus 20 equal minus 40y. So again, I'm going to rearrange the system. So I will move the y and the x on the other side. So their sign will change. So it's become minus 7 equal 14y plus 7x. And I'm going to move y on that side and the 20 on the other side. So I will have 20 minus, because when you move 20 is positive, when you move it to the other side, it's become negative. And here I will have 40y plus 20x. So when I move minus 40 on the other side, it's become positive. Now, after I did my rearrangement, so what do I do now? I'm going to use the Isel test. So after that, I'm going to use Isel test to see what I will get. So I have, oh, you know what? Let me simplify uh, the, the system. So because here we have a common factor, which is 7, and here a common factor, which is 20. So after I simplify, so let me simplify first, then I do the Isel test. So here I will divide here by 7, 7, 7, because 7 is the common factor, and here I divide by 20. So you see, it will make my system more easy to solve. So we'll have minus 1 equal 2y plus x, and here I will have minus 1 equal 2y plus x. As you see here, it's easier than the other one. Now what I do, I'm going to do the test. So uh, 2 over 2, 1 over 1. So this is equal to 1, this is equal to 1. Then they are equal. So what I do now, I do my result. So minus 1 over minus 1 is 1. You see, the three ratios are equal. So this is consistent dependent. So consistent dependent system, which means I have infinity of solution. So we have infinity of solution. Infinite of solution. Now, so how can I use elimination to check if it's infinite of solution or not? So what I do, I'm gonna pick always the system I simplify. So I got 2y plus x equal minus 1, and I have 2y plus x equal minus 1. You see the coefficient of y are the same sign. So what I do, I subtract. So I'm going to subtract here. So I get 0 here. X minus x is 0. And minus 1 minus minus 1 is 0. This is a true statement, so which means infinite of solution. So this is exactly how we solve a system of equations 2 by 2 using elimination. So I hope that you understand the idea behind the lesson today, and please, if you have any comment that can improve my way of teaching, so I'll be happy to hear from you. And thank you for watching the video, and Assalamu alaikum.